AI moved fast again today, and if you blinked, you missed 3 headlines. This is Tech Roundup on the AI Verge, your daily dose of what actually matters in AI minus the hype. Let's get into it. Right now, the largest technology companies on Earth are secretly carrying like $3 trillion in off-balance sheet AI commitments.
Yeah, 3 trillion. It's a completely mind-bending number.
I mean, it's insane. And while they're literally retrofitting Cold War-era uranium plants just to handle the power demands, AI models are quietly writing up to 75% of the code base at Google.
Which is just a massive fundamental shift in how tech is even built.
Right. So today, welcome to the deep dive. Our mission is to basically strip away all those sanitized corporate balance sheets. We're looking at the massive hidden infrastructure of 2026.
Yeah, exactly. We're moving way past that cute chatbot phase now.
Yeah, into an era of just astronomical hidden costs, billion-dollar coding bots, and honestly, the absolute transformation of human expertise. But hey, real quick, if you want to keep tracking these massive AI shifts with us, make sure you hit subscribe to the AI Verge.
Definitely. You don't want to miss what we're tracking.
So, okay, let's just tear right into that $3 trillion figure because, I mean, it sounds like a typo to me.
It really does.
Yeah.
I mean, when you look at the quarterly earnings of companies like Alphabet or Meta, you expect mathematical precision. Right?
Yeah, you look at revenue, profit, the usual stuff.
Right. But the sheer scale of this artificial intelligence build-out has completely broken that traditional financial X-ray machine.
Okay, but how? $3 trillion is roughly the entire gross domestic product of a major European country, like France or the UK, just, floating around in the corporate ether. How do 9 publicly traded tech firms just hide $3 trillion?
Well, it comes down to the mechanics of corporate finance, trying to map onto a completely unprecedented pace of technological deployment.
Yeah.
I mean, normally when a company buys a server rack, that's a capital expenditure.
It hits the balance sheet immediately. You bought a thing, you spent the cash.
Exactly.
Yeah.
But the AI infrastructure boom is moving way too fast for traditional procurement. They aren't just buying what exists today. They're commissioning these massive data centers and ordering specialized silicon years in advance.
So they're basically signing like forward purchase agreements, massive long-term leases.
You nailed it.
Yeah.
When you sign a 10-year, multi-billion-dollar lease for a custom liquid-cooled data center that hasn't even broken ground yet,
Wow.
and you commit to buying $50 billion of hardware to fill it, those obligations often just sit in the footnotes of a financial filing.
So they're classified as off-balance sheet commitments.
Right, under specific accounting rules rather than immediate debt. And one of the major forensic financial reports we're tracking dug into these exact footnotes and found 2 main buckets.
Okay, what are they?
Like $1.2 trillion committed to data center leases and $1.9 trillion locked up in hardware obligations.
That is just, it's abstract future money, right? But the cash burn happening right now is so aggressive. It's actually pushed companies we normally think of as infinite money printers into the red.
Yeah, negative free cash flow.
Alphabet, Amazon, Meta. I read in our sources that Meta and Alphabet are spending more cash out the door than their entire advertising monopolies are bringing in. Which is wild.
Well, it's a terrifying position for a CEO. But, from their perspective, the risk of underinvesting and missing the foundational layer of this next era is vastly greater than the risk of just overextending their cash reserves.
Because whoever owns the biggest physical infrastructure basically owns the future internet.
Exactly. They see the compute constraints and they're just going all in.
Well, let's talk about that physical reality because the numbers get so big, they honestly lose all meaning. If you, want to understand what a fraction of that $3 trillion buys, look at this project in Pike County, Ohio.
Oh man, this one is wild.
It feels like something out of a sci-fi movie. Our sources show OpenAI and NVIDIA are backing an 8-gigawatt AI data center campus being built on the exact site of a Cold War-era uranium enrichment plant.
The historical symbolism there is it's striking. The industrial footprint of the atomic age literally being retrofitted to become the engine of the AI age.
But wait, why a uranium plant? Does it actually matter or is it just for the aesthetic?
No, it makes perfect engineering sense. Because an 8-gigawatt facility cannot just be plugged into a standard city power grid. It'd blow the whole thing out.
Oh, right.
It needs heavy-duty transmission lines, massive access to water for cooling, and just sheer acreage that really only exists at former heavy industrial or nuclear sites.
Just to ground that 8-gigawatt number for you listening. A typical commercial nuclear reactor produces about 1 gigawatt of power. So this single AI campus is going to consume the equivalent output of 8 nuclear power plants.
It's staggering. And NVIDIA is reportedly backing this with a $105 billion line of credit, leasing the site from SB Energy.
$105 billion for one project.
Yeah. And Jensen Huang, NVIDIA's CEO, has been radically transparent about this. He explicitly said the only constraints on frontier labs right now are physical infrastructure and financing, not demand.
The market just wants as much compute as NVIDIA can possibly manufacture.
Exactly. The bottleneck isn't the software anymore. It's concrete, copper, electrical transformers. It's the physical stuff required to build these gigawatt-scale factories.
So it's basically a corporate shell game on a sovereign scale. They're moving multi-billion-dollar capital expenditures into operating leases to keep debt off the primary ledger and just hoping the revenue catches up.
But the revenue actually starting to catch up, which is the crazy part. Look at Anthropic's recent preliminary financials we've been tracking. They just reported $11.5 billion in revenue for their most recent quarter.
$11.5 billion. That's a 14x year-over-year jump, right?
Yes, they were at like $787 million in the same period last year.
A 14-time multiple on a base that was already almost $1 billion. I mean, that's practically unheard of in enterprise software.
It completely warps traditional valuation metrics. Anthropic is eyeing a $2 trillion valuation for an October IPO, and they're projecting like $190 to $200 billion in annual revenue by 2028.
Wow. So when you ask why Meta is willing to go into negative free cash flow, it's because they see Anthropic's revenue velocity and realize the market is just expanding faster than anyone thought. Okay, but wait, hold on. I have a major skeptical question here. If companies are spending trillions of dollars drawing 8 gigawatts of power from old uranium plants, what exactly is burning all that compute? It's not people asking a chatbot for a chili recipe, right?
Definitely not.
You don't burn $1 trillion summarizing PDFs.
No, you don't. The massive power draw comes from a fundamental shift in how we're actually using the technology. We're moving from single-shot inference to continuous agentic workflows.
Agentic workflows.
Yes, and this introduces a massive economic complication that the industry is calling the Inference Paradox.
Let's break down the mechanics of that, because the assumption in tech is always, Moore's Law will save us, computers get faster, silicon gets cheaper, eventually it's all practically free.
Right, that's the historical trend.
But one of the major research firms we track, Gartner, is predicting that the inference costs per agentic workflow will increase more than 5-fold by 5x by 2028. Why is the cost going up 500% if the models are supposed to be getting more efficient?
Okay, so we have to separate the unit cost from the total utilization.
Right.
Inference is just the act of the AI generating an answer.
Okay.
The cost to generate a single token, like a piece of a word, that is absolutely plummeting. The unit economics are great.
So it is getting cheaper.
Yes. But the inference paradox happens because as that basic intelligence gets cheaper, we design systems that use exponentially more of it to accomplish a single task.
Oh, I see. That sounds exactly like induced demand in urban planning.
Oh, how so?
Well, you have a terrible traffic jam, right? So the city planners add 3 more lanes to the highway, but instead of fixing the traffic, the wider road just induces more people to drive. And a month later, you have a 10-lane traffic jam.
That is a flawless mechanical parallel. That's exactly it.
The efficiency of the infrastructure just attracted more consumption.
Yeah. In the early days of LLMs, you typed a prompt, the model processed maybe 500 tokens, gave you an answer, and went to sleep. The compute cycle was like 2 seconds long. Yeah. But an agentic workflow is autonomous. You don't ask it a single question. You give it a high-level goal, like audit our cloud infrastructure for security vulnerabilities, cross-reference them with the latest CDE database, and draft pull requests to patch the top 5 most critical flaws.
Okay, yeah. So to do that, the AI isn't just generating a paragraph of text. It has to break the goal into subtasks.
Exactly. It queries a database, reads the results, maybe realizes it hit an authentication error, writes a script to bypass or fix the error, runs it again, analyzes the output, and it just loops over and over.
It's utilizing a thought, action, observation loop.
Precisely. So instead of 500 tokens, that single task might consume 500,000 or even 5 million tokens as the agent just navigates the environment, makes mistakes, and self-corrects.
Wow. So even if the cost per token drops by 90%, if you're using 10,000 times more tokens per request, your overall compute bill is going to skyrocket.
And companies are walking right into this trap. I mean, one analyst we follow, Scott Bickley, he called the current enterprise environment a blind foray into the AI abyss.
The abyss. That's reassuring.
Yeah, because there's this top-down fever where boards are demanding AI integration and CIOs are deploying these autonomous agents everywhere without calculating the total cost of ownership.
Because they just want the early adopter bragging rights.
Right. They don't realize that an agent looping autonomously in the background to solve some complex coding error is basically running the meter like a fleet of taxis idling in traffic.
And that brings up the ultimate corporate survival metric, doesn't it? Return on investment. Because if you're going to swallow a 5x increase in inference costs and you're paying for data centers that consume the power of a small nation, you cannot justify that by generating marketing copy.
No, you definitely can't.
You need use cases that fundamentally alter the labor economics of your business.
Which leads us directly into the one area where the ROI is so undeniable that it's basically carrying the entire industry right now, software engineering.
Right. If you want to know what's eating all that compute, it is AI writing code. The adoption stats we found from the absolute highest levels of tech leadership are staggering.
They really are.
Google's CEO recently confirmed that 75% of Google's code is now written by AI. Evan Spiegel reports 65% for Snap. And Brian Chesky says 60% of Airbnb's engineer-created code is AI-generated.
Let's just sit with that Google statistic for a second. 75%. Google arguably possesses the highest concentration of elite software engineering talent on the planet.
Yeah, they hire the best of the best.
And if 3/4 of the code being committed to their repositories is generated by a machine, it means the very nature of what a software engineer does has shifted. They aren't writing syntax anymore. They're acting as architectural editors.
Which perfectly explains the mind-bending valuations we're seeing for startups trying to own this space. I mean, there's a platform called Lovable that just hit a $13.3 billion valuation off of $500 million in annualized revenue. And they use a term that I find absolutely fascinating. They call it vibe coding.
Vibe coding. Yeah, it perfectly captures how the abstraction layer is moving upward.
What does that actually mean, though, practically?
Well, historically, a programmer had to translate human intent into incredibly rigid, unforgiving machine syntax, right? You're worried about memory allocation, missing semicolons, dependency conflicts.
The tedious stuff.
Right. Vibe coding suggests that the developer simply describes the high-level logic, the UI aesthetic, or the quote-unquote vibe of the application in natural language.
And the AI just does the rest.
Yep. The underlying AI orchestrates the full stack. It generates the front end, spins up the back end database, connects the APIs, all based on the vibe.
That's wild. And then you have Cognition, the creators of Devin, which is branded as an autonomous software engineer. They're currently raising $1 billion at a $40 billion valuation.
$40 billion.
And CodeRabbit, which focuses purely on AI code review, they just raised $143 million at a $1.5 billion valuation. The enterprise market is just throwing money at anything that promises to replace expensive human developer hours.
But the landscape right now is incredibly fragmented. We're in a highly experimental phase. Developers are using a massive patchwork of tools simultaneously.
Oh, for sure.
A single engineer might have Anthropic's Claude operating in their terminal, OpenAI's Codex assisting in their IDE, and CodeRabbit reviewing their pull requests.
And that fragmentation is creating an opening for some truly ruthless strategic warfare among the platform providers. I mean, my favorite example from our sources is what Cursor just did.
No, the Origin launch. That was brilliant.
It was so aggressive. So Cursor is an AI native code editor. They wanted to attack Microsoft's GitHub, which is basically the undisputed central library where the whole world stores and collaborates on code.
The holy grail of developer lock-in.
Exactly. So Cursor launched their direct competitor, a code hosting platform called Origin, on the exact day that GitHub suffered a massive 6-hour global outage.
It's brilliant tactical opportunism. I mean, GitHub goes down, crippling engineering teams globally. You can't push or pull code. And in that exact window of peak frustration, Cursor announces Origin.
And they included a feature that allows users to seamlessly sync their existing GitHub repos over to the new platform with one click, without losing their commit history.
They removed all the friction. They basically said, hey, while you're locked out of your house, come stay in our fully furnished AI-native mansion for free.
But looking at this from a macro perspective, this phase of everyone using 5 different AI coding tools, it really reminds me of the early days of the streaming wars.
Oh, when every single media company launched their own subscription service.
Right. You had Netflix, then Hulu, HBO Max, Disney Plus, Paramount, Peacock. Consumers initially subscribed to everything just to see what was good, But eventually, subscription fatigue set in.
And the market consolidated.
Exactly. People picked their two favorites and canceled the rest. Right now, enterprise IT departments are letting developers experiment with every AI tool on the market. But eventually, the CFO is going to step in and say, look, we're only licensing 2 platforms. Pick your favorites.
And when that consolidation happens, the multi-billion-dollar valuations for the companies that don't make the cut are just going to vaporize. I mean, the $40 billion price tag on Cognition assumes they become the dominant infrastructure layer for global software development.
If they end up being the paramount plus of coding, that valuation completely collapses.
Absolutely.
But let's look at the human cost of this automation. I mean, I'm skeptical here. If Devin and Cursor are successful, and AI is already writing 75% of Google's code, what happens to the human engineers who used to do that work?
This brings us to a really critical economic and philosophical dilemma found in the research we're tracking. It's known as the cognitive commons.
The cognitive commons. Okay, explain that.
To understand it, we have to borrow from environmental economics, specifically the tragedy of the commons.
Right, like overfishing or overgrazing?
Exactly. In a shared agricultural pasture, it's in the rational self-interest of every individual farmer to let their sheep graze as much as possible. But when every farmer does this, the grass is depleted, the pasture dies, and everyone's flock starves.
Because the short-term optimization destroys the long-term sustainable resource.
Right. And researchers are now arguing that the rapid adoption of AI is going to erode humanity's collective expertise in the exact same way. Well, if a company can boost its quarterly margins by replacing 50 junior developers or entry-level paralegals or junior copywriters with an AI agent, they'll do it. It makes perfect immediate financial sense.
But AI models still hallucinate, right? I mean, they still generate code with subtle security flaws or draft legal briefs with fake precedents.
They do, which is why the standard industry defense is the human-in-the-loop model. Tech leaders always assure us, AI won't replace humans entirely. It'll just require a highly skilled senior expert to oversee the AI, review the output, and act as an editor.
Okay, but here is the fatal flaw in that logic. Where exactly do senior experts come from?
Exactly.
You don't graduate from college as a senior systems architect or a senior law partner. You become a master by spending a decade as a junior associate, doing the tedious, frustrating grunt work that the AI is now doing.
You learn by fixing broken syntax, debugging bad code, writing thousands of mundane contracts.
We are strip mining the apprenticeship model. If the AI is doing all the foundational practicing, the human pipeline of experience is completely severed. In 15 or 20 years, when the current generation of senior experts retires, who is actually going to audit the AI's work?
It's terrifying.
It's like destroying the apprenticeship model in a trade. If we replace all the apprentice carpenters with robots today because the robots can hammer nails faster, 20 years from now, when the robot builds a house that's structurally unsound and starts leaning, there won't be any master craftsmen left who know how to identify the load-bearing failure.
Because nobody was ever allowed to learn the trade from the ground up.
Right.
That is the crisis of the cognitive commons. We treat human expertise as an infinite, naturally occurring resource. But it's not. It's a cultivated resource. It requires thousands of hours of failure and hands-on repetition.
And if we hand that repetition over to machines, we risk a future where AI is generating massively complex, critical systems, power grids, financial trading algorithms, medical diagnostic networks.
And literally no human alive possesses the foundational cognitive framework to understand how those systems work or how to fix them when they inevitably fail.
That is deeply, deeply unsettling. And it's even crazier when you realize this intelligence isn't just staying trapped inside corporate servers or coding environments anymore. It's bleeding into the physical world.
Oh, yeah. The ways we interact with AI as consumers are getting a radical and sometimes, frankly, bizarre physical makeover.
We are seeing the evolution of the glass slab. I mean, for 15 years, the smartphone has been a static, passive window into the digital world.
But as multimodal AI becomes standard models that can see, hear, and process the real world in real time, the hardware has to adapt to become an active participant in our environment.
A perfect example from our recent tech briefings is the new robot phone launching from Honor in China. At first glance, it just looks like a thick, standard smartphone. But hidden inside the camera module is a motorized robotic arm mounted on a gimbal.
Yeah, the main 200-megapixel camera literally emerges from the phone and moves autonomously.
Now, from a pure utility standpoint, a gimbal camera is great for video stabilization, sure. But the real breakthrough is how it integrates with the device's onboard AI assistant. which is named Yo-Yo-O.
The physical embodiment changes everything about the psychological interaction.
Right. When you say the wake word, the camera physically turns to face you. It does a little mechanical dance. The screen displays over 100 different reactive facial expressions. The gimbal actually tracks your face as you move around the room.
It's creating true, hands-free, multimodal interaction.
But do I actually want my phone acting like the Pixar land? I mean, is that the goal?
Well, think about the friction of current digital assistants. If you're cooking and your hands are covered in flour, you can't touch your screen, you might shout at a smart speaker, but it only has audio context.
Fair point.
With a device like the robot phone, the camera acts as an attentive eye. You can hold up a strange vegetable from the farmer's market and ask, "What is this and how do I prep it?" And the phone physically pivots, processes the visual data, and guides you through the task visually and verbally.
Okay, that is pretty useful. And we are seeing less extreme stepping stones toward this across the major hardware manufacturers too. Samsung's Galaxy Z Fold 8 and Google's new Pixel 10 and 11 Pro Fold devices, they lean heavily into what they call tent mode.
Right, you fold the phone halfway, stand it on a table with the external camera facing out, and it achieves that same hands-free, continuous visual chat experience.
But it forces us to ask a profound industrial design question. Do we want personifier AI? Do we want devices that mimic body language, that nod and track us like a digital pet? Or is the ultimate goal just invisible, ambient intelligence where the glass slab completely disappears into our environment?
If sensors and microscopic lenses become cheap enough, you won't need a robotic phone to follow you around the kitchen. The kitchen itself will just be watching you. The intelligence will be embedded in the ceiling, the appliances, the lighting.
Which frankly brings up massive legal and privacy concerns. As AI gains the ability to see and generate physical reality flawlessly, the legal guardrails are just scrambling to keep up.
The collision between raw generative capabilities and human legal frameworks is happening right now in Hollywood. One of our sources highlighted that ByteDance, the parent company of TikTok, just signed the first major AI video deal with the Motion Picture Association.
And it was born out of a legal threat, wasn't it?
Yep. The MPA issued a cease and desist to ByteDance after a hyper-realistic deepfake of Tom Cruise went viral, generated by ByteDance's Dance 2.0 model.
The studios realized they couldn't just play whack-a-mole with individual users posting fakes. They had to go straight to the source.
So in response to the pressure, ByteDance is baking formal intellectual property protections directly into the architecture of their new models, like Dance 2.5 and Dream 5.0 Pro, as well as downstream apps like CapCut.
So they're essentially implementing digital watermarking and content ID filtering at the model weight level, basically preventing the AI from even generating the likeness of protected actors or copyrighted scenes.
It's a fascinating dynamic, whether it's a smartphone that physically nods its head to acknowledge you, or Hollywood forcing digital guardrails into video generation models. We're seeing the messy collision of raw AI capabilities with human norms, legal frameworks, and physical reality.
Okay, so while these massive macro-level shifts, the trillions in infrastructure, the evolution of hardware, the legal battles are reshaping the global economy, the underlying efficiency gains are actually available to individuals right now.
Yes, the same agentic logic that is driving the enterprise compute boom can be harnessed on a micro scale for personal productivity.
Exactly. So let's bring this massive architectural theory down to the ground. How do you and I use this to protect our own cognitive commons and scale our own workflows this weekend?
Right, let's get into the actionable stuff.
We're going to walk through 3 specific workflows you can set up right now. First, let's solve the most common AI problem, that robotic, cringy writing style.
Oh man. If you use an LLM to draft emails or documents, you know the telltale signs. The AI leans on overly complex vocabulary. It uses words like delve or tapestry constantly.
Always delving into the rich tapestry.
Always. And it constructs these sentences with passive, flowery structures. It's grammatically flawless, but it's stylistically hollow.
So here is the mechanical fix for ChatGPT users. Go into your settings, navigate to plugins, and under skills, enable the humanize writing toggle. The workflow is simple. Draft your copy normally, then type the command /humanize writing to force the system to strip out the algorithmic fluff.
But if you want true control, the real secret is in the structural prompting. You need to constrain the model's natural tendency to overpredict complex tokens.
Right. And to do that, try appending this exact instruction to your next writing prompt. Write in technical English using ASD STE 100 as a style reference.
ASD STE 100. It's brilliant.
For those who don't know, it's an aerospace standard for simplified technical English. It was designed to ensure that maintenance manuals for jet engines are universally understood regardless of the reader's native language.
It explicitly forbids flowery adjectives, restricts sentence length, and forces direct, active voice verbs.
Applying that standard to an AI model instantly kills the robot voice and produces clean, punchy, authoritative text. It'll save you hours of editing.
That is such a smart use of a niche industrial framework to override the default behavioral tuning of an LLM.
Okay, the second weekend hack is about scaling your own knowledge acquisition. Have you ever watched an incredible 40-minute YouTube tutorial? Maybe it's a deep dive into financial modeling or complex coding framework, and you understand the theory, but a week later, you've completely forgotten how to actually execute the steps.
Oh, all the time. It's the gap between passive consumption and active retention. You absorb the narrative, but you lose the structural mechanics.
Well, you can automate that retention. Find the YouTube video with a clear, repeatable framework and grab the raw transcript. Open Anthropic's Claude and utilize their skill creator function.
So you provide Claude with the video title, the creator's name, and you paste the full transcript in.
Yep. Then you prompt the AI to extract the core operating rules, identify the common mistakes the creator warns about, and format the ideal output.
You're effectively asking the AI to reverse engineer the expert's cognitive framework directly from their spoken words and map it into a procedural algorithm.
And Claude will output a file called skill.md. You take that markdown file and upload it into your personal Claude settings under capabilities. You have just permanently captured that expert's methodology.
So the next time you face a similar problem, you don't have to rewatch the 40-minute video. You just invoke that custom skill, feed it your own data, and the AI applies the creator's exact framework to your specific situation.
It's amazing. And that transitions perfectly into the final, most advanced workflow. This is a practical micro-implementation of the agentic loops we discussed earlier, applied to personal knowledge management. It comes from a user named Zhao in our sources, who solved the fundamental flaw of the second brain.
A second brain being a personal database, right? Like Notion, Obsidian, or Joplin, where you store articles, notes, and research.
Right. And the system usually fails because of capture friction. At the exact moment you find an interesting article, you're forced to stop, decide which folder it belongs in, tag it, organize it. The cognitive load is too high, so people just stop saving things.
Zhao completely eliminated that friction using the free open-source app Joplin. He wrote a lightweight Python script called joplincapture.py. Now, whenever he finds a piece of data, this script dumps it blindly into a single, unorganized IndieBox folder.
There are 0 decisions required at the point of capture. You just dump the data and keep moving.
But an unorganized inbox is just a digital hoarder's closet. I mean, how does he actually retrieve it?
This is where the agentic workflow comes in. Every night, while Zhao is asleep, a second script called joplinfiler.py works up. This is a local AI agent.
I love this.
It autonomously reads every single note in the INBBOX. It analyzes the content, scores it against Zhao's existing folder taxonomy, and makes a routing decision.
So if the agent reads a highly technical note about firewall configurations and determines with high confidence that it belongs in the cybersecurity folder, it just moves the file autonomously.
Exactly. And if the confidence score is low, it leaves the note in the INBBOX and applies a needs review tag for Zhao to look at in the morning.
It's an autonomous background categorization loop. It evaluates the environment, takes action, and logs the result.
But the absolute smartest part of this implementation, and this ties directly back to our discussion on the cognitive commons and the dangers of blindly trusting AI, is how Zhao deployed it. He didn't just turn the agent loose on its life's work.
Right, because it could misfile everything.
He ran the Joplin filer script in dry run mode for a full week.
Meaning, the agent executed the thought process, but was blocked from actually taking the physical action of moving files.
Exactly. For 7 days, the agent just generated a text log of what it would have moved and where it would have put it. Zhao reviewed the logs over his morning coffee. It's literally like hiring a highly enthusiastic intern to organize your filing cabinets, but making them practice on photocopies for a week before you hand over the keys to the actual files.
Only after the AI proved its competence did he turn off dry run mode and grant it write access. That is the gold standard for integrating autonomous agents. Verify the logic, establish the human-in-the-loop oversight, and only then delegate the execution.
By the way, if you love breaking down these practical weekend hacks as much as we do, don't forget to subscribe to the AI Verge channel so you catch every deep dive.
We have covered a truly massive amount of ground today. I mean, the scale of what's happening behind the scenes is almost difficult to hold in your head all at once.
We started in the murky waters of corporate finance, looking at how the tech giants are masking $3 trillion in infrastructure commitments through forward leases, driving companies like Meta into negative free cash flow to build 8-gigawatt nuclear-adjacent data centers.
We dissected the inference paradox, unpacking why the cost of running AI is predicted to 5x as we transition from simple prompts to looping agentic workflows that consume massive amounts of compute to execute complex tasks.
We looked at the immediate fallout of that capability in the software engineering gold rush, where AI is writing 75% of Google's code, driving $40 billion startup valuations, and triggering strategic platform wars like Cursor's attack on GitHub.
We confronted the slow-moving tragedy of the cognitive commons and the very real danger that by automating the entry-level grunt work today, we are destroying the apprenticeship pipeline that creates the master experts of tomorrow.
We watched the technology physically manifest in the real world through multimodal robot phones and saw how Hollywood is forcing digital guardrails into the very weights of the models to protect physical likenesses.
And we brought it all back to your desktop, giving you the specific scripts and frameworks to humanize your writing, reverse engineer expert knowledge, and build an autonomous, self-organizing second brain with verified oversight.
The ground is shifting incredibly fast. The constraints of the future are not going to be software limitations. They're going to be concrete, copper, and electrical power.
Absolutely.
But as you set up your auto-filing scripts or test out new coding environments this weekend, I want you to consider one final paradox. We've spent this hour talking about the sheer, mind-bending cost of silicon intelligence, the trillions in hidden leases, the 8-gigawatt power plants, the 5x explosion in the cost of running an agentic loop.
It's astronomical.
If the cost of running these artificial brains continues to multiply and the energy required pushes the global power grid to its absolute limits, what happens when the math stops working? What happens if the compute bubble pops and the cost of inference simply becomes too high for the average mid-sized company to sustain?
That is the trillion-dollar question.
Will we see a bizarre inverted future where human expertise, the very thing we're currently trying to automate out of existence, becomes the ultimate, highly sought-after luxury good? Because at the end of the day, running a brilliant human brain on a turkey sandwich and a cup of coffee is infinitely cheaper and vastly more energy efficient than powering an 8-gigawatt AI data center.
Protect your cognitive commons, everyone.
Keep doing the hard work of learning, because the human mind might just end up being the most cost-effective intelligence on the market. Thanks for taking the deep dive with us.